Okay, cool. Hey, Bethy. This is Chris, and we are just doing this real quick. My lesson, super informally, I guess. So, today we're going to be learning about Bayes' theorem. Welcome to my classroom. I'm Mr. Goodman.
I'm Chris. Nice to meet you.
Nice to meet you. Today we're going to be learning about Bayes' theorem, which is just like an idea in probability. So, I should ask, do you have any background in probability?
I'm taking a stat class right now, 301, but
sweet.
But I have no idea what Bayes' theorem is.
So do you know what like conditional probability would be? Like,
I don't think so. It's not ringing a bell.
Okay, cool, sweet. I wouldn't typically explain that in a lesson because hopefully students already know that, but I'm gonna explain that with you. And that's not a big deal. So I want to think about a situation. Okay, so I have a bag of beans right here, jelly beans. 2 are grape. There's 4 of them. Here's your proof.
Mm-hmm.
2 of them are grape, and 2 are blue, 2 are red.
Right.
So, in this, what is the probability that I pick a grape jelly bean? Out of 4. 1/2, right? Yep. So then, now what Bayes' theorem is going to teach us to be able to do is say, based on this first bean, knowing that I picked a blue one first, what's the probability that I'm going to be able to pick a grape one now? So, kind of like that. We'll explain it in better detail in a second. So, okay, so, yeah, that's pretty simple, but not really exactly what we're doing. So, another situation to kind of explain it a little bit better. So, first bean. So, we know it's 1/2 chance I pick a blue one, right?
Right.
So, first bean, I'm going to pick it at random. Wait a second. We don't know what it is.
Right.
I'm picking a bean at random, putting it into my pocket right now.
Okay.
We don't know.
You didn't see.
No one saw it.
No one saw
I
it.
didn't see it. He didn't see it. No one knows. No one knows what's in here because he can't see in it.
Got it.
It's not see-through. So now I want to say, at random, put it in my pocket without looking at it. I choose another jelly bean at random, and it is grape flavored. So now I pick one, or not grape, it's blue. So now I pick a jelly bean, and it's blue, right?
Okay.
So my second jelly bean is blue. So now we're saying, what is the probability that the jelly bean in my pocket is blue?
Oh, okay.
Based on the fact that the second one's blue.
Yeah.
So it's cool with Bayes' theorem. You can use Bayes' theorem to predict like probability of stuff in the past using the outcome that you get. And then you could also say, so what's the probability that it's a licorice jelly bean in my pocket? So would you have any clue to do that right now? Maybe, kind of. You could maybe try to come up with something random. Cool. So hopefully you'll know how to do that by the end. So quick question. Is it equally likely that the jelly bean in my pocket is either flavor?
Mm-hmm. Oh, wait.
Like, is it equally likely, like, if I put one in my pocket and then I pull out a blue one, is it equally likely that the first one in my pocket is blue or red? Like, which one's more likely, I guess?
Oh, probably red, I guess, right?
Yeah.
Or blue.
Yeah.
Was it
Cool.
red? Was it red?
Yeah, it's red. It's red.
Okay.
Because one blue's already taken, so it's kind of
it's more likely to be red. Got it.
Yep. So you're kind of given like a couple things. Let's say the event, like you have event A, that's saying I choose the jelly bean in my pocket is blue, and event B is the jelly bean in my pocket is red. So the probability of event A is going to be like just 1/2, right? Because you're saying the probability that the first jelly bean I picked is blue, and then the probability that I picked the second one's red. I'm starting right now. It's okay.
That's okay. No.
Hey, Bethy. Thanks. So then we're going to say, so probability of A, we'll write this down. Okay.
Go for it.
So A is the event that you pick a red, or a blue, sorry, that's what we said. And B is the event that you pick a red. right?
Mhm.
So the probability that the first jelly bean we picked is a blue would be. So the probability that the first jelly bean that I put in my pocket is blue.
Oh, just out of the blue?
Yeah.
Out of all the,
Yeah.
like one half.
Yeah, yep, exactly. And then so the probability that I picked a red is also 1/2, right? Okay, so now what Bayes' theorem is teaching us to do, it's still working.
Okay.
Cool. Bayes' theorem is teaching us what is the probability of A with the condition of B.
Okay.
So saying with the condition that the second jelly bean I picked was blue, or was red, what's the probability that the first jelly bean was blue?
Okay.
Does that make sense?
Mm-hmm.
So that's what conditional is, just saying, like, based on this, what's the probability of that?
Mm-hmm.
Yeah, cool. So, yeah, that's what we're going to kind of go over. This is just, we're not going to actually figure all this out. We're going to do some better, more fun examples.
Cool.
Yep. Okay, a common use. So, oftentimes in the real world where they actually use Bayes' theorem would be like medical testing, which is like the example we're about to do kind of explains how they could use this. Like, you go in and they tell you, you get like tested for a disease, and they say like, based on the testing, like there's a 98% chance if the test says you don't have it, there's a 98% chance that you don't have it. So you can say, based on like all this information, what's the chance that you don't have the disease? Like, actually, I guess. So this problem will kind of explain it a little bit better. So like for like in the medical field, like if someone tests for a disease, positive means that they have it, negative means they don't.
Mm-hmm.
Right? Cool. I want to make sure because they use that. So we're going to go over this example as a class. What else too? In the fictional town of Atlantis, doctors have developed a test for the Atlantis death flu. They know that the probability that a random person in Atlantis has the Atlantis death flu is 0.01. So that's our first probability we're given. So the probability that any person in Atlantis has the flu, so that's A, is 0.01.
Mm-hmm. So
they also know a person who has the Atlantis death flu has a 95 probability of testing positive. So, probability that they test positive, so P for positive, is going to be 0.95. But that's saying, sorry, I messed that up. The probability, so it says, probability that, they also know a person who has Atlantis death flu. So do you see how that's like our given condition?
Yeah.
So it's saying because it's given that they have the death flu.
Okay.
So A is going to be saying like that they have the death flu.
Okay.
So given that they have the death flu, 95% of the time they're going to actually test positive.
Oh, okay.
So it's possible for someone to have the death flu and not test positive.
Yeah.
They can test negative.
Yeah.
So then, 95% testing positive disease. While a person who does not have it is 94% probability of giving a negative test result. So the same thing, just like the opposite. So we're saying the probability of a person not having it, given that probably someone testing negative, given that they don't have it, which we'll label B, is going to be 94%. So let's say that a patient comes to a doctor because he wants to get tested. So a patient's coming to get tested for the flu. What's the probability they actually has the death flu? They actually has the death flu if he's positively tested for it. So a random patient comes and he's saying like, okay, I want to be tested for it. So he's going to get tested for it, right? Okay. And he got tested positive.
Uh-huh.
So the given is that he's tested positive.
Positive.
But we want to say A or B, like, is he going to have it?
Or not,
so we're saying, what's the probability that he tests positively for it? Wait. That he actually has it and tests positively for it. So P of probability that he actually has it is going to be A, given he tests positive.
Yeah.
So we need to find this probability right here.
Gotcha. Nice.
So, but do you see how these two probabilities are different?
Mm-hmm.
Like the probability that he tested positive given that he has it is different than the probability that he has it given that he tested positive.
Oh, okay. Yeah.
So those are flipped, and that's exactly what Bayes' theorem does.
Okay.
So this is like the equation for Bayes' theorem. This is basically what it all boils down
Oh,
to.
sweet.
So you have P of A given B equals P of A times P of B, thank you, given A over probability of B.
Do you press escape?
Escape. Cool.
Okay, cool.
So this is the theorem, or this is the equation for Bayes' theorem. So this is what you would use to find this guy right here.
Mm-hmm.
So for this guy, you'd say P of A given P equals, so first you have P of A, so you have P of A, and then you switch the two, so times P of P given A over P of P. So now we just have to go up here and find all those and plug them in, basically.
Cool.
So you got P of A is 0.01, P of P given A is 0.95. But now this example is a little bit different, actually. So so basically, P of P is going to be, you got 0.01 times, I'm writing this down. Okay. I'm going to add a condition because it's going to be really hard to explain that since, yeah, whatever.
Go for it.
Condition is that P of P is, let's say, 0.8. So there's 80% chance that they test positive, which means that's not realistic. Let's say a 0.08% chance they test positive. So P of P down here is going to be 0.08. So then you're going to plug these in to your handy dandy calculator and get a number. And that's going to give you the condition that you want,
Okay.
basically.
Easy enough.
So that really shouldn't need to know how to navigate the equation, but
Yeah.
but like more than the equation, you have to be able to understand like what separates this probability from this probability. Like you have to be able to say like which ones are different and how are they different. So we solved for that. So do you like understand the equation for the most part?
Yeah, I think so. I don't have it memorized, but
Okay. Yeah, that's fine.
Okay.
And do you understand like how you would decide like the hardest part I think is going to be going through like looking at the situation and saying which probability goes with which number that they give me.
yeah, I just need to know like what A and B stand for
Yeah.
and all that stuff.
Cool.
Yeah.
Cool. And so the next thing on my list to do, so I kind of just do that. We do that little activity as a class. And then the next thing that we're going to do is I pass out this little exercise here that has like 2 problems that are going to go a lot more smoothly than the one I just did. And I'm going to probably edit that one that I just did to make it a little more simple. It would help if it was like a class that was actually going through it, but yeah. So we'll do that little exercise, and then at the end of the exercise, I'll pass out my exit card, which will be Chris's homework for the night. And the exit card is what I'm actually going to grade and assess to see like what students do. But I don't think I really have to go over that in this video. So
Cool.
That's about it.
All
but
right.
the exit card is how I would assess him to see if he learned it. And hopefully that's where like I think him doing the exercise on his own would, and then I'd be like walking the room or working through it with him to make sure he knew what was going on. So thanks, Chris.
Thank you, Grant.
Yep.
Learned a lot today.
Yep. Thank you, Bethy. I'll see you tomorrow in class.